Most of us have heard of wormholes, mysterious tunnels that scientists believe could allow travel between distant galaxies or regions of space. Recently, scientists mapping a 3D model of our galaxy made an astonishing discovery. They found what looks like an interstellar tunnel that seems to connect our solar system to another distant star system. While this tunnel isn't exactly a wormhole, it behaves somewhat like one. It appears to connect two separate regions of space, which could mean that there may be paths across the galaxy that we never imagined existed. In this video, we will discuss this fascinating discovery in more detail. So get ready to be thrilled because what scientists have found will blow your mind. Our sun is located in a region of the Milky Way called the Orion Arm. Research shows that the sun and the entire solar system are surrounded by a vast, hot, low-density bubble of gas known as the local hot bubble. This bubble, roughly 1,000 light-years across and shaped like a stretched oval, extends over a large area around us. It means we're surrounded by this hot, sparse gas cloud as we orbit the center of the galaxy. It is purely coincidental that the sun seems to occupy the central position in the local bubble. This position helps scientists study the bubble's characteristics through the different temperatures, densities, and cosmic rays encountered at various points. The local hot bubble is incredibly hot, with temperatures estimated between 1 and 2 million degrees Celsius. This is much hotter than the surface of our sun, which is about 5,500 degrees Celsius. You might be thinking that if the temperature inside this bubble is so intense, then it should also affect the solar system and the objects inside it. However, even though the gas inside the bubble is so hot, it's also very low in density. In fact, the density of particles within the local hot bubble is thousands of times lower than the density of air on Earth. This means there are very few particles in the space within the bubble, and because the gas inside the bubble is so sparse, this high temperature doesn't directly affect objects within it, including our solar system. Scientists believe the local hot bubble formed approximately 14.4 million years ago when around 15 massive nearby stars exploded as supernovae. These kinds of clustered supernova events aren't unheard of in the galaxy. Stars are almost always born in clumps, with a single molecular cloud producing hundreds or even thousands of stars in a single go. Most of these stars are small red dwarfs. Some are mid-sized stars like the Sun, and the remaining ones are huge. Those huge stars are on a track to end their lives in a supernova blast, and because they were born at about the same time, they're likely to explode at roughly the same time too. When a single supernova goes off, it can carve out a cavity around it, pushing away the interstellar medium with the force of its shockwave. Plus, near the end of its life, it blasts out intense bursts of high-energy radiation, which contributes to the excavation project. Combining hundreds or even up to 1,000 such supernovas can provide the energies needed to form something like the local bubble. In January 2022, a paper in the journal Nature found that as the bubble expands, it sweeps interstellar gas and dust, which collapse to form new stars on its surface, but not inside. These new stars are typically in molecular clouds like the Taurus molecular cloud and the open star cluster Pleiades. Our sun did not form along with the stars that would eventually die and carve out the local bubble. It entered the bubble's region only about 5 million years ago. Astronomers can determine that through a combination of the sun's velocity within the Milky Way and the presence of radioactive elements found on Earth, the solar system will continue traveling through the local bubble for another 10 million to 20 million years, but over time, the bubble will disperse and its shell will fragment, with the rest of the interstellar medium flowing in to fill the void. Millions of years from now, you would never know the drama of what happened there. Well, astronomers have recently used the eROSITA telescope, the main instrument on the Spectrum Renin Gamma mission launched in 2019 to map the local hot bubble. Their findings reveal that this bubble has an unusual shape and shows varying temperatures across different regions. Surprisingly, scientists also discovered what appears to be a tunnel-like pathway pointing toward the constellation Centaurus. This discovery supports the theory that the local bubble was created by supernova explosions, which blasted out and heated the surrounding gas. Scientists believe that the tunnel might connect the local hot bubble to another low-density bubble nearby, suggesting that the galaxy may be filled with interconnected bubbles and pathways. This idea, proposed back in 1974, suggests that our galaxy could have a vast network of these hot, low-density bubbles connected by tunnels or gaps in the cooler interstellar regions around them. However, researchers don't yet know where this tunnel leads. It could connect to other cosmic structures like the Gum Nebula, neighboring bubbles, or molecular clouds. Study co-author Michael Freibergen, an astronomer at Germany's Max Planck Institute for Extraterrestrial Physics, said in a statement that what we didn't know was the existence of an interstellar tunnel towards Centaurus, which carves a gap in the cooler interstellar medium. In addition to the 3D map of the local bubble, the team also created a census of supernova wreckage, superbubbles, and dust, which they incorporated into the map to build a 3D interactive model of the solar system's cosmic neighborhood. This included another previously known interstellar medium tunnel called the Canis Majoris Tunnel. This is thought to stretch between the local bubble and the Gum Nebula. The discovery of this interstellar tunnel is an exciting development, potentially offering insights into how supernovae shape our galaxy's structure. If this tunnel is part of a larger structure, we could be looking at a hidden network within our galaxy, shaped by the explosive power of dying stars. Such a network could change our understanding of how matter, energy, and particles move through space. These interstellar tunnels might play a key role in transporting cosmic rays, gases, and even newly forming stars between different regions of the galaxy. They could act as cosmic highways, making it easier for energy and particles to travel across vast distances. Understanding this network could help scientists explore the impact of supernova explosions beyond just individual bubbles, revealing how these events shape the galaxy's cosmic weather and influence star and planet formation. Continue for watching exciting space discoveries video. Please subscribe and leave a comment for suggestion and mistakes. Thanks.